Good day, grade 12s. Welcome to our session for today. I am Miss Ngayo. I'll be taking you through electrochemistry, one of those topics where you go like, sure, you don't know how to answer them, especially the electrolytic cells. Grab your set, get ready. We'll go through the exam-like questions. Try to listen up a bit about how difficult it is because it's actually very easier to do. You just have to follow up with me. Firstly, you have been taught already in your classes. Your teacher has taught you what is a galvanic cell, what is an electrolytic cell. We know that these are cells and there are energy conversions in them. So what we know firstly is about the energy conversions. We know that in a galvanic cell, this is the cell where chemical energy is converted into electrical energy. And then an electrolytic cell, this is a cell now whereby electrical energy is now converted into a chemical energy. Now, the principle for these cells remain the same. Where is the site of reduction for a galvanic cell? Reduction takes place at the cathode. Now, remember, cathode is the cell where reduction takes place, and then in an electrolytic cell, still reduction takes place at the cathode. And then the site of oxidation for the galvanic cell is the anode. Also for the electrolytic cell is the anode. Now you'll ask yourself, what about the differences? Now remember, the polarity for an electrolytic cell is determined by the power source. How is it connected? In an electrolytic cell, the power source, the side that's connected to the positive terminal of the battery is now the anode. And then the side that is connected to the negative terminal of the battery is now the cathode. Whereas in a galvanic cell, it's the opposite. The cathode is positive and then the anode is negative. The principle of which reaction takes place remains the same though. Now we say that the positive electrode in a galvanic cell is the cathode. And then the negative electrode in a galvanic cell is the anode. Now in the electrolytic cell, the positive electrode is the anode. And then the negative electrode is the cathode. Now the N-ions migrate to there. Remember, the N-ions will be negatively charged. So they are attracted to the cathode. Like charges attract each other. So now your cells, they are attracted to the cathode. And then your cations for a galvanic cell will be attracted to the anode. Whereas in an electrolytic cell, your N-ions are attracted to the anode. Remember, in the anode of an electrolytic cell, it is positively charged. Therefore, negative charges will be attracted to the positively charged side. The cations will be attracted to the cathode. So one of the simpler ways to memorize is to say NN for an electrolytic cell and cat. Then you know that it's the opposite for the galvanic cell. The electrode that gains mass, this is where this is where reduction takes place. Where does reduction take place? It takes place at the cathode. And then the electrode that loses mass is at the anode, because remember, oxidation is the loss of electrons, whereas reduction is a gain of electrons. And then electrons flow from the anode to the cathode. Now this remains the same for your entire cell. This is how you remember the summary of the entire cell. If you know the polarities and you know that the site of reduction and the site of oxidation remain the same, then you are almost there to be able to answer your questions. Now, I want us to look at an exam-like question. This is a question paper that we had from the Eastern Cape Trial Examination 2024. How do you then now tell which cell is which? This, on my left-hand side, this cell is actually a galvanic cell. How do you know that this is a galvanic cell? Look at where it is connected to. Our half cells are connected to the voltmeter. This means that this cell is an electrochemical cell and is a galvanic cell. We know what energy conversion is taking place there. Then how do you know where is the electrolytic cell? You look at where your cell is connected, what your electrodes are connected into. Our electrodes in a galvanic cell are connected to a voltmeter, and our electrodes in an electrolytic cell are now connected into a power source, which is the battery. So this is the battery. This tells us that this is an electrolytic cell. We already know what reaction takes place. Now our main focus today is how to answer electrolytic cell questions, which become a bit tricky because I know sometimes you understand the galvanic cell better than the electrolytic cell. Now the first question that you had was define electrolysis. We know that we always get our definitions from the examination guideline. But I want to make it a point that you remember when you are writing your definition on an electrolysis, don't forget that this is a process. So you follow your examination guidelines for the definitions, you will never go wrong. Now it says, let's go back to the statement. A few drops of phenolphthalein are added to concentrated sodium chloride solution. The solution remains colorless. Carbon electrodes P and Q that are connected to a battery is dipped into the solution as shown below. Now you know that this is what you're supposed to be doing when you get into the exam. You know that the shorter line represents the negative terminal. The shorter line represents the negative terminal. So we know that this side is negative. So electrode Q is negative because it's connected to the negative terminal of the battery. And then electrode P is positive because it's connected to the positive terminal of the battery. Now remember, this is your electrolytic cell, and since you know the polarities, that in an electrolytic cell, the positive terminal is connected to the anode. And in your electrolytic cell, your negative terminal is connected into the cathode. You know the principle of reactions taking place there. So we know that NOx, meaning that at the anode, that is where oxidation takes place. Now, oxidation is the loss of electrons. How do we write oxidation from the standard half reduction table? We write it from right to left. And then we know that this is the cathode, and at the cathode, that is where reduction takes place. So red cat, meaning that reduction takes place at the cathode, whereas oxidation takes place at the anode. Now, another thing that you know that you have in this cell, examiner has given us sodium chloride. So we know that this is one of the processes that are actually taking place there, but I know it becomes tricky sometimes because you don't know what will be reacting with what. You have to break down your electrolyte solution because this is going to be a solution. You're going to form your cation, which is sodium ions, and you're going to form your anion, which is your negative ion. Now we know that the anions are negative. Which side are they going to be attracted to? They're going to be attracted to the anode because anode is positively charged. Unlike charges attract. Like charges repel. Now we have got sodium ions because this is a solution. There is a competition with water there. And remember, water can auto-ionize itself and can form hydrogen ions and hydroxide ions as well. However, the competition is really between the hydrogen ions and the sodium ions as to which one will be actually taking place here. Now remember, if you look at your table, we have got at the table the sodium. Table 4b, I'm using table 4b, please note, we have got sodium. Sodium is there at the top, and then we have got hydrogen. So where is the hydrogen we're getting? We're getting the hydrogen from this water here, which is at minus 0.83. Now between these two, remember in the table, it is actually increasing oxidizing ability as you go down. And it is increasing reducing ability as you go up. Meaning that the one that you find on top of the table, when you are looking at them, the one that you will find at the top will mostly undergo oxidation, whereas the one that you find at the bottom will mostly undergo reduction. But remember, this is actually an electrolytic cell, so things will be twisted. The one that will be at the top would be the one that would undergo reduction, and the one that will be at the bottom will be the one that will undergo oxidation. And between sodium ions and the hydrogen ions, water is the one that will be undergoing. The sodium ions will not react at all in the electrolysis. They will not form part of any reaction. So they will be spectator ions. Then the one that will be taking place is the water, the hydrogen ions from the water. Now you may be confused because we have got a lot of waters that we have here. We have got water which has got the 083 number, which is the MTN number. That is how you can easily remember it as to which water to choose, because we have quite a lot of water that we have in this table. Now you go down, when you're going down the table, you will see that you will get, that is where you're going to get your, that is where you're going to be getting your chlorine. So we also have got chlorine at the bottom. Now we know that this is the water that will be taking part in the reaction. Water will be reacting, sodium ions will not be reacting. And then chlorine will also be forming part of the reaction. So going back into the question now you have already figured out as to which reaction will be taking part where. Remember, we said let's just keep the polarity of the electrodes here. So we said that this is negative, we said that this is positive. So we know that sodium ions are not taking part in the reaction. We are only left with chlorine ions, and we are left with hydrogen ions. So which water are we using? The 0.83. So already you know that these are the two that will be taking place. You don't have to memorize any of these reactions because they are all there in the table for you. So you just have to write them. And remember, now we're saying that chlorine and ions will be attracted to the positive side, which is the anode. Now at the anode, we know that is where oxidation takes place. Now, how do we write reactions for oxidation? We write them from left to the right. And then how do we write reduction half reactions? We write them from right to the left. So basically, we know that the chlorine ions will be oxidized at the anode, and then they will be written from oxidation. We write it from right to left. Sorry, oxidation we write it from right to left. Sorry, and then your reduction half reactions, we write them from left to the right hand side of the table. We copy them. You don't memorize any of them. Now let's come back to the question. It says, Write down the name of the component that shows that the above cell is an electrolytic cell. How did we define that this is an electrolytic cell? By the presence of the power source, which is the presence of the battery. And then it says, write down the name or formula of the gas produced at electrode Q. Remember, electrode Q is connected to the negative terminal, and because it's connected to the negative terminal of the battery, this makes it the cathode. This is where now reduction is taking place. Now, a reduction is taking place at the cathode, which is the negative terminal of the cell. Therefore, how do you know which gas is it going to be? Because we have got two gases here. You go back to the table. Now, we said that the water is the one with the empty N number. This is the water that is taking reaction, that is reacting here. And then we know that the second reaction that is taking place here is the chlorine. Chlorine, where is the chlorine? Let's find it. It's here at the bottom. This is the chlorine. So this is the chlorine. So these are the only two that will be that will be reacting in this cell. So there is a half reaction at the cathode, half reaction at the anode. So we said this is the half reaction that is at the anode. So we're going to write it from right to left. And then this, now, the water is the half reaction that is at the cathode. We're going to write it from left to right. So remember, at the electrode Q, this is our cathode. That now means that the gas that will be produced there should be the hydrogen gas. So this is how you answer it, that this is the hydrogen gas. So hydrogen gas is the gas that is produced at the electrode Q, which is negative. That is where reduction takes place. Then the next question says, write down the half reaction that occurs on electrode P. Remember, our electrode P is positive and is the anode. So because this is the anode, this is where oxidation takes place. You go back to the table, you come to the the electrode P. You're gonna write exactly this reaction. You copy it from right to left. Now please take note that when you are copying this reaction, you only write a single arrow. No double reaction, no double arrow, because this is a half reaction. So let's copy this into answering. Let me show you how you write it. You will simply write it this way. You will simply write it. Let's write it now. It's actually going to be 2Cl minus, single arrow, and then you write, let's go and copy. Remember, don't be shy to copy. We are copying things exactly as they are. So it's 2Cl minus. Now we're writing it from right to left. And then we have Cl2 plus 2 electrons there. So you come and write it as Cl2 plus 2 electrons. Then you get marks. No double arrow. Don't omit the charges, because remember, learners, we are copying this from the table. So we need to copy it as it is. Now the next question is on right. Phenolphthalein is colorless in an acidic solution. Now the examiner is telling you about phenolphthalein's color. Let me try and erase this. Now it says phenolphthalein is colorless in an acidic solution and pink in an alkaline solution. Write down the color of the solution around electrode Q and formula of the substance responsible for the color. Now let's go back. What did we say is taking place in our electrode Q? Remember, in our electrode Q, we said we have got hydrogen gas. being produced there. Now, when you go back to the reaction, you will see from your table that in this reaction, in this electrode, what is actually taking place, you have got your water undergoing reduction. So it's from left to right. So your water gains electrons and it actually releases hydrogen gas. And now there is also this substance that is produced there. So we have got OH minus ions that are released. What does that tell us? Remember when we were doing acids and bases, we actually said that when you release substances that release hydroxide ions are basic, and substances that release hydronium ions are acidic. So if now hydroxide ions are actually being released in electrode Q, this means that it is now basic. And then you have got 9.6. So what is the substance responsible for the color? You have to be able to say it's the hydroxide ions that are actually released at the cathode. And then 9.6 says an electrolytic cell is set up for the purification of copper or that contains zinc and platinum impurities. After the purification of the impure copper was completed, 1,38 times 10 to the power 2 minus 2 mole of electrons were transferred. The initial mass of the cathode is 2 grams. Which metal besides copper will be oxidized? Choose from zinc or platinum. Now, I'm more interested on the calculate the mass of the cathode after the purification. Actually, for you to be able to answer this question, you have to look at what you are given and be able to write the stoichiometric reaction that is taking place there. Now, what you are told is that you have got copper electrons, and the copper electrons are equal to, has got number of moles, that is 1,38 times 10 to the power minus 2 mole. Now remember that N, like your stoichiometry, N is equal to mass over molar mass. But how do you now? You have to first be able to do the stoichiometry, the ratio, because 1 copper solid will give how many number of electrons? Remember, 1 copper solid releases 2 number of electrons because we're using copper 2 plus ions. So that means that the number of electrons now you're going to be having here will be half of that. 1,38 times 10 to the power minus 2 mole. These will be the number of moles of copper now. Will be equal to the half of that. Now, after you have done that, you can now continue with your stoichiometric question, which is answering the question, calculate the mass of the cathode after the purification. After you have determined that it's going to be half number of moles, you come and substitute with your formula, N equals to mass over molar mass. You go and take the molar mass of the copper. I think it's 63.5 if I'm not mistaken. You don't memorize these molar masses. You just come and look at them in the formula sheet. So you're going to have half times 1,38 times 10 to the power minus 2 is equal to mass over 63.5. Then you will be getting now the mass of the copper. Therefore, the mass of the copper will be equal to that. You can use your calculator and answer and write the mass. But now remember, this is the mass that will be gained. So to get the total mass of the cathode, you have to add that 2 grams. This mass that you got there. That is it for today, grade 12. I hope you enjoyed that, and I hope that you will use some of the skills you have learned in applying towards your examinations. I want to wish you good luck, and from me, I have just a few words for you to say that life is like Newton's third law. Remember the Newton's third law? It actually says that when object A exerts a force on object B, object B will simultaneously exert a force of equal magnitude that is oppositely directed to object B. Now, what does that mean? That means that whatever effort, whatever force that you put in and into the universe, you're going to receive it backwards, simultaneously, meaning at the same time. So you put in much effort, you put in much force, you're going to get those excellent results. I wish you all the best. Good luck.